Okay, now starting to talk about the actual properties of parallelograms. See, a parallelogram, it's a quadrilateral, it's a four-sided image where all of the opposite sides are parallel. This is parallel to this line. This is parallel to this line. Notice I had to use different markings. That's because the single arrows, they're only parallel to each other. If I put a single arrow here, according to that notation, that would be me saying that all the sides are parallel to each other, which they're not, only the opposite sides. So I have to use a different set of markings. If I had something that was 6 sides and the opposite sides were parallel to each other, then I'd have to use single arrows, double arrows, and then eventually triple arrows. Anyway, the rules that we just covered on the previous set of notes start applying to this as far as like, if they look the same, they are the same. If not, then they're equal to 180. Okay. Then we start getting into diagonals. Okay. When you have the parallelogram, this diagonal and this diagonal, is it possible that they could be the same measure, the same length? Yes, if you're talking about a square or a rectangle, but that's not always the case. All right, you can see right here, the length of this line is not the same length as that line. However, diagonals do always bisect each other. That means that they cut them equally in half. All right, line AC is cutting line DB in half, and vice versa. DB cuts AC in half. That's why I was able to put these little tick marks. This half is the same measure as this half. This half is the same measure as this half, or in other words, segment AE is congruent to segment EC. Segment DE is congruent to segment EB, which is what I put over here. All right. One diagonal does also form two congruent triangles, meaning that this triangle right here is the same exact size and measurements as this triangle right here.